Okay, so we're solving differential equation now, and actually solving a differential equation is really just an integral, because when they ask you to solve the differential equation, they give you this. What is this? This is a derivative, and when they say solve the differential equation, what do they want you to find from the derivative? Okay, solve the differential equation means find what y equals, or f of x, given a derivative. That's what we did in chapter 6, only we did lots of crazy ways, like homogeneous differential equations and Bernoulli differential equations. These are just basic, like what we did at the very beginning, find the antiderivative. So you're given a derivative, you want to find the function it came from, so you're going to take, basically this means take the y would equal the integral of 1 plus e to the x squared dx. So that's what we have to do. We have to find this integral. Any ideas here? I think that's a good plan, expand. I thought maybe I'd stump you on that one, but Morgan, I can't stump you. Okay.
So I said, like the first.
It is the first one, yes, okay. I should have kept that a secret from you for a while. Oh well. Okay, so.
Yeah, I can see that.
All right, so expand. All we're going to do, we haven't worked out the integral yet, so I'm just going to FOIL that. So, little review on foiling something like this might be good, huh? You're probably a step ahead of me. So if I FOIL, I get 1 plus the outer is going to be e to the x. The inner is plus e to the x again. And the last, what's e to the x times e to the x? E to the 2x. Very good. What do you do with exponents when you multiply? Add them. Add them. Okay. So now the terms that these two actually go together to give you 2e to the x. Okay, so I'm integrating 1 plus 2e to the x plus e to the 2x dx. Okay. So this is a sum and difference rule. Now, I could just go through and just find the antiderivative of each of these separately without separating, but there's one part of this that will cause a problem. Well, let's just, what's the antiderivative of 1? X. What's the antiderivative of e to the, or 2e to the x? 2e to the x, because the antiderivative of just e to the x is e to the x, the 2 is just a constant. So, but what's this antiderivative? It's not 2, that would be the derivative of e to the 2x. It's going to be plus 1/2 e to the 2x. Why? Yes, because this, the rule for this is the integral of e to the u du. And your u would have to be what? 2x. You have to use the du here. You have to do the substitution. Why? Because du is not just 1. So the du would be 2 dx, and then you'd have to substitute the dx with 1/2 du. So you don't actually have to write the work if you realize that. So you can say, well, I know that I would have to pick u is 2x and the du would be 2, so I'm going to have a 1/2. So I don't expect you to have to show this work, okay? So that's why we don't have to like write it as 3 separate integrals as long as you know that. If you need to do that, that's fine with me. But I don't expect you to show that work. So this would be the antiderivative plus c. Okay, and I just wanted to throw that solve the differential equation in because you'll have that. You might have a problem that says something about a slope field. A slope field is just a differential equation. They give you a dy over dx. You aren't drawing any slope fields if you're having nightmares already about little slashes on a graph. So no, they give you the give you the slope field. What? Yeah, that was just this year. I know it seems like forever ago, but so if this is the same. Slope field is really just a differential equation. That's all it is. So you won't be drawing any, all of they'll be is integrals. Every problem on your assignment is an integral, even if it doesn't say it right up front, like this one. All right, so let's look at another example. This is just going to be a regular integration one. So the integral of 1 minus x over the square root of 1 minus x squared dx. That could be 18. What's the problem with it being 18? There's an x on top. Using the square root in the u. Every single time you use the square root in the u, you're going to end up with another square root on the bottom. If you let u equal that, the derivative will be negative 2x over the square root of 1 minus x squared. Now, technically, I mean, that could work out for you, because then you might end up with just like an integral of du type thing. So sometimes that could work for you. But the deal with this is Morgan's already told us actually what to do to start. Because of these two terms on top, we're going to want to separate this. Because, you know, we could use normal substitution and just let the bottom be 1 minus x squared, and that would take care of this x part here. Or we could use one of the inverse trig, and that would be okay if the x wasn't there with just the 1. So if we separate this, you can always separate the top of a fraction. Each of these on top and this on the bottom of both. So I'm going to separate it right as the integral of 1 over the square root of 1 minus x squared dx minus the integral, or you could write plus the integral of negative x over the square root of 1 minus x squared dx. So because these two will take different techniques to work out. And I would like to use Pablo's idea on this integral just to see what happens, because I think it's an interesting idea. So for this one, what formula does this actually match up with right away? The arc sine. The a is what here? 1, and the u is x. Just x. So it's the arc sine, so it'll be, this antiderivative is just the arc sine of x. Just x. Yeah, please don't write x over 1 like as a final answer. All right, and now on this one, here's what you would probably choose to do. You would probably choose to let u equal 1 minus x squared. I'm not going to do that. Okay, we're going to see if this works. We might go back to this. We're going to use Pablo's suggestion and let u equal the square root of 1 minus x squared. And then du is 1/2 1 minus x squared to the negative 1/2 times the derivative of the inside, negative 2x. So that's, I already have that written here. So negative 2x over the square root of 1 minus x squared dx. See how this whole thing, if I get rid of that negative 2, see how that is the whole integral?
Doesn't the 1/2 and negative 2?
Yeah, they cancel off.
Oh yeah, the 1/2 and the negative 2. Okay, so yeah, that should be 1/2. So the du is the entire integral. So is it okay if I just write this as plus the integral of du? I didn't use the u. I picked the u really nicely, so the du worked out to be the whole integral. What's the antiderivative of du? No?
U plus C.
It's u plus c. So what was my u in this problem? U was the square root of 1 minus x squared. Wasn't that my u? Okay. Some of you are like, whoa, I don't believe you, Mrs. Kern. I don't believe you can do that, right? I don't like this. It's not normal. Well, try it. Try just letting u equal 1 minus x squared.
I got a different answer.
You shouldn't have. If you let u equal 1 minus x squared, then du is negative 2x dx, right?
Yep.
Okay, so then you'd have the integral of, let's see, that it would be 1/2 du on top over the square root of u.
Oh, it's over square root. I just had.
Yeah.
Never mind.
Each other.
I put the negative, I added a negative. Okay, so for this integral, then you write it as 1/2 the integral of u to the negative 1/2 du. Add 1 to the power, 1/2. Divide by 1/2. 1/2 divided by 1/2 is gone. Plus c, and u was 1 minus x squared, so it works out exactly the same either way. I love that when integrals are like that. It doesn't happen very often. But. So is there more than one way to work them out sometimes? Yeah. Okay. All right, so now I want to do a couple of trig ones. And then we'll call it a day and I'll give you your assignment as far as notes go. So I had a good trig one back here. All right, so the integral of 1 over cosine theta minus 1 d theta. So this is number 9. We'll just do a nice even 10 examples. Okay, any suggestions on how to start? What?
If it was cosine squared, it would be.
What's the problem with using like u equals cosine theta minus 1?
It's sine of theta.
You're going to get a negative sine of theta for your du, and you don't have that. Okay. And it would be nice if this were cosine squared theta, wouldn't it?
Yeah.
Could we make it cosine squared theta?
If you wanted.
You can't square it. You cannot square things.
Or we can multiply the top and bottom by cosine.
What?
Wouldn't it be because you always have the y squared then?
Yeah, then you'd have a squared on the other side. So,
You can just leave that experiment.
yeah, you can multiply top and bottom times something. What is the suggestion in the basic rules? By a conjugate. Pythagorean. See how in the example, they've got a problem similar to what we have? And they multiply the top and bottom by 1 minus the sine of x. A conjugate doesn't have to always involve a radical. A conjugate means the same two terms, but the opposite sign in between. So what should I multiply the top and bottom by here?
Cosine plus 1.
Cosine theta plus 1. Now what that's going to do for us, well, on the bottom, what will I end up with? Cosine squared theta
Plus minus 1.
minus 1. And on the top, I'll have cosine theta plus 1. Yuck. Oh, maybe it's not that bad.
So the bottom now.
The bottom now could be a Pythagorean identity. What's the main Pythagorean identity you should know from pre-calc?
Sine squared plus cosine squared plus 1.
Sine squared, yep, plus cosine squared is 1. So, see, how would I make this cosine? Basically, I need to get here cosine squared minus 1 and see what that equals. So, could I subtract 1 from both sides? And then subtract sine squared from both sides? So then over here I have cosine squared theta minus 1 equals negative sine squared theta. So as long as I rearrange it properly, you know, so what could I replace cosine squared theta minus 1 with? Okay, negative sine squared theta. And I still have a horrible looking thing. Any ideas of what I could do now?
Then could you separate?
Select your u. U would be what?
Negative sign squared theta.
Okay, so the derivative, we're going to have to use the chain rule here. What's the derivative of the outer part?